Hovertech. Just a button away.
In this video tutorial, we'll explain how to generate your chain VBMeta.img, VBMeta vendor.img, and VBMeta system.img. Now, this comes in handy for those who are looking to modify their super image, whether you're targeting your super, your product, your vendor, your ODM, whatever. But your device requires a chain VBMeta, or it has a VBMeta verification, that's AVB version 2. So you can't just simply modify these partitions and flash your device. It's going to cause a boot loop because they are not they are being the integrity is being verified by your VBMeta and it is failing integrity. So you have to sign them appropriately and generate the corresponding VBMeta file. So that's what this guide is going to explain. Now, for those looking to just bypass your FVB altogether, yes, you could have done that easily in version 1 by flashing a magic patch boot or modifying the boot image. And the earlier versions of AVB2, you could have flashed a blank VBMeta. But with the recent wave of Unisoc devices we are seeing, you have to generate a VBMeta image. If not, it's going to fail. All right. And even at that, even you can't even change the flag of VBMeta. We'll talk about the flag shortly. If you try to modify the flag from 0 to maybe 2, it might still cause a boot loop in some devices, even if every other thing is identical. So it's just crazy, really. But let's talk about how to generate or change VBMeta images. Of course, you need the Linux interface. I have mine here. If you look closely, I have my keys folder where all my public keys are situated. I started this from the VBMeta. So I'm going to make some assumptions in this guide. This particular key was extracted from my primary key or my private key, sorry, which is this guy over here. So I have my AVB tool, I have my dtbo.img because it is needed for this particular image I'm working with. You'll see that shortly. And then I've extracted my super image into the components, my product, my system, my vendor. Yours might be different. And of course, I have my VBMeta images. So for this guide, I'm making some assumptions. I'm assuming that you are familiar with generating a custom VBMeta. If you are not, I will link to a guide on how to do that. At least you have the basic knowledge of what you are looking at here, your AVB, your keys, and your private key and public keys. You have an idea of what those are in relation to VBMeta. Then I assume you are familiar with signing an image with AVB2, that you have a private key that was used to sign your VBMeta image, at least the VBMeta.img. If you don't have that private key, then this is not going to work. Then I assume you also you know how to extract public keys from the VBMeta image, and also how to generate your custom public key from your private key or whatever private key you'll be using to sign your images. And then, of course, you know how to unpack your super image. All right, so with all this in place, let's jump into the guide proper. I have structured the commands, so it's going to be easy for you to follow along. But I'll explain what I'm doing. So the first thing I will do is to verify or check the information of my VBMeta images. Now, the reason I'm doing this is because when I'm generating my custom image, I'll be referring to some of the information in the VBMeta image to craft my command. So I'll just run you through the important ones. Now, looking at the VBMeta image, you can see the SHA. This is 2048, so I know what my primary key needs to look like. I can see what the public key looks like. So I can verify if the key I have matches what we used to sign this image. So I have my flag is set to 0. So that means when creating my command, I will also leave my flag as 0, because while 2 disables AVB check on some models, you will find out for some other models, Trying to disable the AVB verification by changing your flag from 0 to 2 tends to cause a boot loop. So you might have to leave it at 0 and rely on signing your images properly, which is what I'm going to be doing. Now, the descriptors, the change partitions. So this particular VBMeta image is verifying the boot image, is verifying the VBMeta, the boot partition, sorry, the VBMeta underscore system partition, and the VBMeta underscore vendor partition. Now I also have some props which you can see here. So when crafting my VBMeta, my custom VBMeta, I will just throw in all these props so that I just have a replica of my original VBMeta. Now take note, we also have hash descriptors. I have one for DTBO. So I'll be including that in my command. I also have a hash descriptor for product. I have a hash descriptor for system ext. So when you see my command where I craft my VBMeta, you understand the command. I'm literally copying a lot of this information or trying to create a VBMeta that is identical in a lot of ways, in literally all ways, to the original, and then making a couple of changes here and there. So I have the information of my main VBMeta. I will clear that. I like to keep a very clean screen. I'll do the same. So make sure you are saving this information maybe to a text file because you need to reference them later. Now my VBMeta system here, I can see the key. You notice that the key is different from what I had in my main VBMeta image. So it's not a problem as far as you have the key for the main VBMeta.img. You are literally good for the rest of the way. But what I want to take note of in this VBMeta system are the props that I have here, a hash descriptor. You can see this is here is system. So this is verifying my system partition. So if I want to think out system partition, I need to make sure my VBMeta system is in line or well signed, and also checking my system image properly. The signature of my system image matches what is in my VBMeta system, essentially. So I'll clear. Now VBMeta vendor. Let's see what that looks like. Now you notice that the public key is also different from what I had in my VBMeta image. Also 2048, fine, no problem there. I take note of the props, and then hash descriptor vendor. So this is verifying the vendor partition. So that means if I wish to think out my vendor partition, I need to ensure that my VBMeta vendor, matches whatever signature or signature of my VBMeta vendor matches the signature of my VBMeta partition or image. All right. So there needs to be that balance, check and balances for everything to work fine. All right. So I have my information saved. So let's jump into the main guide. So the first thing I like to do is to generate or recreate the stock VBMeta, right? So my command will look something like this, and I will explain what I'm essentially doing. So what this command is saying here is Python AVB2 general information. I'm using this key as my primary key. This is the algorithm 2048. You recall you saw that when I checked the information earlier. Then the flag I'm leaving as 0 because I told you if you change the flag to 2 in some cases, it actually causes a boot loop. All right, but you understand why I'm doing this particular step shortly. Then these are my change partitions, my boot, and I have my key in the keys folder, the one I extracted from the original VBMeta. I have my VBMeta system also using the original public key. I have my VBMeta vendor using the original public key and information. All this I extracted from the information that I got from my VBMeta image. And then you see I have descriptors which I found here. So I'm including descriptors from the product. You notice you recall you saw something like that earlier on. Descriptors from my system ext, for my DTBO. That's why I have my DTBO image. So all these images have to be present in order to import their descriptors. That is why you notice I have my DTBO and some other files in the same folder as my AVB tool. So I'm importing their descriptors into the VBMeta image which I'm crafting, and then I'm giving it a padding of this. Now this particular model doesn't have the DTHB in hex editor. When I check, there's no DHTB. So I don't need to run the padding script. If you've been through a VBMeta generation guide, you understand the padding script part of the whole thing. I don't need the padding script for this because there's no DHTB. And then the output is going to be this file. So when I run this command, I would have a file named VBMeta stock here, right here. So to confirm that my information matches the original VBMeta, I will then run this guy, which is going to run a check on this. So now if you look at the VBMeta I've generated, you see it looks pretty similar to that. So it should be a replica of your stock VBMeta. The reason why you try to regenerate your stock VBMeta is because you need to have a baseline. You understand? Before you start talking about making modifications, you need to confirm that all your public keys are correct, your private keys are correct, your commands are correct, everything is intact. And the best way to do that is to first regenerate your stock VBMeta. If you can generate a clone, a replica of it, it means you have a very good baseline. And when you flash that, it ought to boot fine. If it flashes fine and it boots fine, it means you have a bridgehead. So you can then start making changes little by little. So whatever change you make that causes a boot loop would clearly tell you that change is the problem. You understand? Instead of just going in and modifying this and that, just try to establish a baseline, something that boots fine, and then you can start making changes little by little. That is how you get it done. Okay, so now that I established my commands and keys are all correct, I will now go into this thing. Now, the sequence of these commands is very important. You understand? Because if you get the sequence wrong, you get a bad outcome. So now I'm going to generate my custom VBMeta, and I'll explain what the command is doing. The normal AVB tool and the keys and algorithm, I'm leaving my flag as 0 still. Now, look what I'm changing here. For boot, I'm leaving the default key, the default public key, because I'm not flashing a modified boot in this case. But if you are, you can swap it out. But for my VBMeta system, you notice I'm using a different public key now. And for my VBMeta vendor, I'm using a different public key. What I'm telling AVB2 here is that I want to sign these two partitions, my VBMeta system and my VBMeta vendor, with custom keys. This is the public key. I have a private key. So once I generate VBMeta now, AVB2 is expecting that when I sign my VBMeta underscore system.img and my VBMeta underscore vendor.img, the keys should match what it has on this record, because I have told it that I have a public key. I've given it a public key to use, and I'm promising it that I have the corresponding private key to sign the images. So recall I told you I extracted these public keys from a private key which I have. So that's what essentially what I'm telling AVB2 here. And then notice I still kept descriptors. You might or might not keep the descriptors. You might still find that it might boot up just fine, even if you knock out all the descriptors. But I just like to put them in place because you never know what brands implement and check these days. So just leave everything in place. Only change what you really need to change. Try to keep everything as much as in place as much as possible. That's my rule of thumb. So now that you understand my custom VBMeta generation, I will run that. As I said, this doesn't have a DHTB, so I'm not running a padding script. So if I check my directory now, I have a VBMeta custom right here. Now the next step is to now modify my partitions. In this case, I'm modifying my system and the vendor. So I will not be running this command, but this is essentially what the command to look like. You are going to resize the system image. Ideally, you should create a system directly before you mount, and then you make your changes, and then you resize the image and fix the file system. Same thing as your vendor. You need to create a vendor directory which you mount your vendor image in to make your changes on mount and then whatnot. So once you are done making your changes, it's the same principle for your product, your ODM, whatever it is you're modifying, the same principle. So please do not get restricted by the commands itself. Try to understand the principle and you can replicate it across several device types. So now I'm going to, once I'm done modifying my vendor and system in this case, you now have to add the hash trees to the images. So I'm going to add the hash tree to my system image using this command. So what I'm just doing really is just asking AVB to add the hash tree to this image called system a underscore a.im, because this is what I modified above. If you recall. So the partition name is system. Do not generate this. Then I added the props, and then all good. So I will just rerun this and add the corresponding. I got all the information from. You can always from your VBMeta underscore system image, you get this information I used to add the hash tree. So just copy out what you need. All right. Or sometimes you can even run an AVB check on the system image itself. So whatever information you need to get your hash tree of the system image to match what you have in the original, you just need to copy them out and then integrate them into your command. So it is taking a while because it's modifying a large image. In case I'm wondering where I got these props from, you can run your AVB2 check. That is image. You can run this command, your AVB2 info image on your system image, and you grab whatever information you have from there, to craft your hash tree command. So I've done that. Now I'm going to generate my VBMeta system. So the commands are pretty straightforward. VBMeta, my key, my algorithm, flag, and descriptors. Now I'm asking to include descriptor from system image, which I just added the hash footer. So by doing this, you see that my VBMeta system is going to be very, very close, a close replica to my original, because I imported the hash tree footer from the original into my modified system image, and I'm using that descriptor to now create my VBMeta system. So a lot of things are going to be identical. Just the few changes I made will just change a couple of hash algorithms or sizes here and there. That's all that really changed, but most of the structure will be the same, and I like doing that because it's much neater. So, and then I add my padding, regular padding, the size of the VBMeta file itself. So I'll run this, and I will have a file named VBMeta system custom here. So now I've added the hash rate to my modified system image, and I've created the VBMeta system image from that. So I'll do the same thing for vendor. So just repeat the same process for whatever partitions you have modified. So essentially, what you just do is you need to extract the hash tree information or whatever information you can from your original images. And then when crafting your final images, after you've modified, you need to re-add those hash tree footer informations using this command. then use that newly hashed image to generate your VBMeta image so that everything looks identical and just a few things change. It's very important you do this. That's how I'm able to keep track of a lot of changes and not get confused. Even track bugs. All right. So I'm doing the same thing for my VBMeta vendor. I'll give it a while to run. And then I'll now generate my VBMeta underscore vendor image. Descriptor I'm importing descriptor from the vendor image, padding size, same size as the VBMeta size. I don't need to do any padding for these particular types, and that is done. So if you look here now, you have all your custom images here. So what you just do now is to flash your modified partitions. That is in this case my system and my vendor, and also flash the VBMeta image, VBMeta system image, and VBMeta vendor image. All right. So some people prefer to just repack the super image with the modified files. Yeah, that works. I'll link to a guide on how to do that. You might just want to, instead of flashing individual files in Fastboot, you might just want a way to just flash all your meta images and super image in your pack file at once that will reflect your modifications. Yeah, that works. It's fine. But that's beyond the scope of this guide. I link to get on how to repack your super image. So that essentially is how to generate your chain VBMeta image, VBMeta system image, and VBMeta vendor image using AVB tool in a Linux interface.